Okay. So all of you are here. We have started with a new link. Fine. So I was talking about preparation of iodobenzene, conversion of aniline to iodobenzene. How we are going to do? We are going to treat aniline with sodium nitrite and HCl, where we are going to get the benzene diazonium chloride, which further on treatment with potassium iodide, we are going to get iodobenzene. Fine. So there is no requirement of copper iodide and all. That is not required. Please remember the role of copper iodide or copper powder in Sandmeyer's reaction or Gutterman reaction is they helps in the formation of a radical. They helps in the formation of a radical. They are radical mediated reactions, right? But that is not required when it comes to preparation of iodobenzene. So therefore we are just treating with potassium iodide. And same logic is applicable when it comes to fluorination. One thing here is hydrogen fluoride, HF, is a weak acid. What is the reason? Why hydrogen fluoride is a weak acid? That is because it will not release the H plus ion easily. What is the reason? That is due to the bond strength, which is high in hydrogen fluoride. Higher bond strength in hydrogen fluoride. That is the another reason why fluorination will not happen by the Sandmeyer's reaction. Please remember, try to understand this. Fine? So ಹಾಗಾದ್ರೆ when it comes to fluorination, one of the reagent which we are going to use here is, what is this? HbF4. We have discussed this one in first P. Whether it was the S block. That is fluoroboric acid. HbF4 means fluoroboric acid. Okay, na? So that's where we have the HbF4. Now whenever I will treat with this compound with HbF4, I am going to have the fluorinated product, or I can have the diazonium salt, where it will be converted into Cl minus will be replaced by BF4 minus. Cl minus will be replaced by BF4 minus. Fine. So now, what is that molecule? Another product will be naturally, it should be HCl. Okay. Now, what is the name of this molecule? Benzene diazonium. Benzene diazonium fluoroborate. Benzene diazonium fluoroborate. That will be the diazonium salt. Now we have another type of diazonium compound where instead of halide it can be BF4. So where in the general structure R N2 plus X minus, I had told respective halide, even it can be BF4 minus. It can be even BF4 minus. That's why we have one of the benzene diazonium fluoroborate. Right? So which on slightly heating, can be converted into fluorobenzene. What can be other products? What can be the other products? Other products will be nitrogen, and one of the fluorine is attached. So leftover is boron trifluoride, BF3. Boron trifluoride. So that's where we have the fluorination. Fine. You can skip this step. You can directly write this one where aniline treated with HbF4, it can be converted into, or it can be benzene diazonium chloride which can be converted. Normally it will be done like this only. Fine. So NaNO2HCl and HBF4 together we can have, or we can split the reaction. So first this one, then this one. Fine. So that's where we have the benzene diazonium fluoroborate. Okay. So which later get converted into fluorobenzene. That means when I am talking about fluorobenzene preparation, we have one step, second step and third step. Total we have the 3 steps. First is conversion of aniline to diazonium chloride, benzene diazonium chloride. Next, treating with fluoroboric acid to have this particular product. Normally what they will do, NaNO2HCl, fluoroboric acid together they will treat. That is also fine, but we will go with splitting the equation. So that's where we have the conversion of aniline to fluorobenzene. All of you have understood? Conversion of aniline to fluorobenzene. Okay? So that's where we have the reaction. Now, when it comes to R, that is alkyl or phenyl group, and then we have the N2 plus, but X minus can be halides or it can be fluoroborates. It can be fluoroborates, anything. Even that compound exists. All of you have understood? Now, all are important only. The next one is conversion of diazonium chloride to benzene, respective benzene. Conversion of benzene diazonium chloride. Benzene diazonium chloride to benzene. How this reaction will be done? This reaction will be done by using reducing agents, mild reducing agents, like a solvent like ethanol, it can be used, or phosphinic acid. Phosphinic acid. What is phosphinic acid? I have the benzene diazonium chloride. When it is treated with H3PO2, that is nothing but phosphinic acid, hypophosphorus acid. H3PO2 means hypophosphorus acid. When I will treat with hypophosphorus acid, now it will get converted into benzene. It will get converted into benzene. And phosphinic acid itself will get converted into phosphorus acid. Phosphinic acid, that is hypophosphorus acid, or we can call it as phosphinic acid, which will get converted into orthophosphorus acid. Orthophosphorus acid. Right? So that's where we can convert aniline to benzene. This is the reaction. Conversion of aniline to benzene. What is the oxidation state of phosphorus here? Oxygen 2 minus 4. Right? Here 3. So it will be phosphorus oxidation state. Minus 4 plus 3. It should be plus 1. What is the oxidation state of phosphorus? It is plus 3. Because 3 2s are minus 6 and plus 3. Right? Minus plus 3. Because that minus 6 will go to that side. Right? So that's where we have the plus 3. That means phosphorus from plus 1 it is getting converted into plus 3. And in turn, this molecule, benzene, which is attached with the nitrogen, is getting converted into benzene. That's where we have the reduction which is happening. That's where we have the reduction. And this molecule itself, it is getting oxidized. Fine? So anyway, these reactions will happen in the presence of water. Same way we can have the another method for conversion of aniline to benzene, but only thing here is condition, that is we are going to use ethanol. We are going to use the ethanol. Now ethanol will get oxidized. What should be the product? What will happen when ethanol will get oxidized? What will happen? Oh, the products are different. What will happen when ethanol will get oxidized? Can anyone? So what will happen when ethanol will get oxidized? It will get converted into ethanol. It will get converted into ethanol or acetaldehyde. Ethanol, right? It will get converted into ethanol. So that's where conversion of aniline to respective benzene through formation of benzene diazonium halides. All of you have understood? Any doubts? Fine. So that's where we have the application. Now another reaction is there. I told benzene diazonium chloride should not be exposed to the high temperature. Even moderate high temperature should not be exposed. It should be maintained under cold condition. What will happen if benzene diazonium chloride, they are highly soluble because they are salt. They are highly soluble, no problem. They are soluble in nature because they are salt. What will happen if I expose them even to 280 degree Kelvin? 280 Kelvin. What will happen? 280 is not a high temperature, please remember. 280 might be somewhere around more than 5 degrees Celsius. Okay? So even to that temperature if I expose, they will get hydrolyzed. They will get hydrolyzed as phenol, OH. So to make you understand, so bond will be split because nitrogen is having positive charge. So there will be positiveness, delta positive. So OH minus H plus, OH minus will come here. So that's where we have the phenol. Nitrogen will be released as it is. H plus will go with minus. That's where we have the HCl. That's where we have the HCl. All of you have understood? So this is what will happen if benzene diazonium chloride is exposed to bit high temperature. Not even high temperature, even room temperature. They will get hydrolyzed and there will be formation of phenol. Very easy method. This is how aniline can be easily converted into phenol. Aniline can be easily converted into phenol. Convert aniline into benzene diazonium chloride and naturally then they will get converted into phenol if you bring it to room temperature. That's where we have the reactions. All of you have understood? So that's what it will happen. Same way, next one is conversion of aniline to nitrobenzene. Conversion of aniline to nitrobenzene, because from nitrobenzene to aniline we know. How we are going to do that one, nitrobenzene to aniline? By the reduction, by using iron, right? Iron and HCl. We can have the aniline to nitrobenzene to aniline. That was the first method for the preparation of aniline which we have discussed. Nitrobenzene to aniline. Now we are converting aniline to nitrobenzene. Right? So that's where we have the aniline which will get converted into benzene diazonium chloride, which will get converted into benzene diazonium chloride, which on treatment with HbF4, what will happen? Just now we have discussed. Which on treatment with HbF4? So it will get converted into benzene diazonium fluoroborate. Benzene diazonium fluoroborate. Right? So which further on heating in the presence of copper powder and sodium nitrate. In the presence of copper powder and sodium nitrate, when you heat it, they will get converted into nitrobenzene. NO2 plus NaBF4 plus only this much NaBF4, then nitrogen, then nitrogen. Fine. So that will be the product. So that's how aniline can be converted into nitrobenzene. Fine. So we have discussed about nitrobenzene to aniline, where I told iron and HCl combination will work out because there will be formation of hydrogen gas, which helps in the reduction of nitrobenzene to aniline. That's what we have discussed. Here it is reverse, aniline to nitrobenzene. So this is what we can do. First we have to convert it into benzene diazonium fluoroborate, which on treatment with sodium nitrate in the presence of copper powder, when you heat it, now there will be formation of nitrobenzene. All of you have understood? Whether I am clear? So another 2 minutes. Okay? Now we are going to preparation of organic dyes, coloring compounds. Preparation of organic dyes. Okay na? Don't write DIES. That will be different. DYES. Preparation of organic dyes. That's where I told benzene diazonium chloride is having huge application. So this is very simple. So we have, it's a coupling reaction. Please remember, dyes will be prepared by using coupling reaction. Okay. Now N2 plus Cl minus. So we have benzene diazonium chloride. Okay. So I will treat with the phenols. Please remember, all the carbons here, they will be attached with one hydrogen. Same way, one hydrogen, I will show it here. Fine. So this is not a simple, with different compound, it's phenol only. Same way, same benzene diazonium chloride. In another way, it can be treated with aniline. Okay. Fine. Now, this H and this Cl minus will be released as HCl, and this nitrogen will be attached to this carbon. N double bond N OH. Okay na? So OH. So that's where we have the compound. So now this molecule can be called as parahydroxyazobenzene. Parahydroxyazobenzene. Okay, so that's where we have the molecule. Now here what will happen? Once again, this H and this Cl minus, HCl will be released. Once again, we are going to have the benzene, nitrogen, then aminobenzene. So it can be called as para-aminoazobenzene. Para-aminoazobenzene. That's where we have the condition. Okay. Now this will have the orange color. This will have the orange color, orange crystals, and this will have the yellow color. So like this we have the different coloring compounds or crystals. Okay, bond. Okay, fine. I will use different one. Okay, so that's where we have the benzene with nitrogen. So this will be yellow colored. Okay. Now same way we will be having another one where it is okay na? So that is orange dye, this is yellow color dye. Fine. So this is a coupling reaction. So what is happening? So this Cl minus, it will go with H. It will be released as H plus. So therefore N2 plus can attack over here. Right? So to make you understand, this will be released as like this. Sorry. So this will be released as like this. H plus it will be released. So due to that, what will happen? So positive, negative, HCl. Right? So now this one become negative. So positive will attack. So that's what it will be happening. Fine. Same logic is applicable here also. So this reaction will happen like this. Negative, positive. Cl minus will go with positive. N2 plus will go with negative. So that's where coupling will happen. Fine. So that's where these are the two organic dyes, which will be the example. One is orange, another one is yellow. One mark question they will ask. The color of the dye which will be found when aniline is treated with, benzene diazonium chloride, which is that color is yellow colored dye. Fine. Same question, when phenol is treated with benzene diazonium chloride, the color of the product, so that will be orange color. Fine. So all of you have understood. One mark question can be asked from this. Fine. So by this we have done with the amine topic, right? So now when it comes to the aniline to toluene, bit important. Aniline to phenol, that is also a bit important. Then Sandmeyer's reaction, right? That is important. Gattermann reaction, almost they have asked these reactions, but here reaction they have not asked, but they have asked about color of the compound. For 1 mark, they will ask the color of the compound.
You show that the H bond for phenol, it will go towards the carbon, but that phenol will show negative.
Where is phenol? Okay, here. Okay.
Phenol will show positive resonance, right? So there already will be
No. So don't worry. This is just to make you understand. Mechanism is there. This is just to make you understand. I have shown that why we are getting HCl. Just to tell that H plus, then Cl minus. Okay. So since positive, negative will be there, positive will come and attack. So that's why we are going to get the product. Okay. So naturally, hydroxyl group will have the positive resonance, no doubt. Okay, na? So in reality, negative density will be there. Since it will show the positive resonance, in reality at ortho para position, there will be negative electron density. That is due to positive resonance. In that way also we can tell. But this is just to make you understand. Okay? Any doubts? So by this amine topic is over. But any doubts? So organic chemistry, please remember you have to practice the reaction, right? And the reaction with the name of the person is very, very important, no doubt. And in alcohol phenols, we have seen many of such reactions. and even amines we have seen many such reactions. But when it comes to amines, name of the person with respect to reaction is less, but there are reactions which are important. Still they have asked. Okay, with the name of the person, reaction is less when it comes to amines, and topic itself is a bit small topic compared to alcohols, phenols and ethers. But we have another huge topic, that is aldehydes, ketones and carboxylic acid. So try to practice whatever organic chemistry topic we have done, try to practice the reactions. Otherwise altogether it will be difficult for you people. Fine? In that way I will stop today's class. Thank you. Thank you very much.